I'm Anil Kumar, and in this video we'll explore reflections of functions. If f of x equals to 2x minus 1, write an equation to represent y equals to minus of f of x and describe the relation between the two functions. So we have a linear function f of x and we want to know what happens to this linear function when we are considering minus of f of x. Okay, so for convenience we already have a graph of f of x. So that is a straight line, you can see that, with y-intercept at minus 1. So this is minus 1, slope of 2. So that is 2. So this point here is 1, 1, correct? Then again slope of 2. So it gives you 2, 3. Similarly, if you go downwards, we get the point with 1 unit to left, it is minus 1 and minus 3, right? 2 below minus, so minus 3, and then we get minus 2, minus 5. So we have these 5 points on the given line, f of x equals to 2x minus 1. So let me write down these points in the form of a table, correct? Then we'll compare. So we are given x points, and for the fx points are, so if I take minus 2 times 2 is 4, 4 minus, that is minus 4, minus 4 minus 1 is minus 5. That is how you get this point. Similarly, you can do calculations for minus 1, you'll get minus 3. For 0, you'll get minus 1. For 1, you're going to get 1. And for 2, 2 times 2 is 4, 4 minus 1 is 3. So we get these 5 points. Now, when y is minus of f of x, it means what? F of x, let me rewrite this particular equation here. So we'll say y is equals to minus of f of x. Now f of x is given to us as 2x minus 1, so I could write like this, minus of, within brackets, 2x minus 1. So when you open the bracket, you get y equals to minus 2x plus 1. Is it okay? So that is f of minus x. Now let us plot the points for this function, which is for us, we'll take the same x values and calculate for minus of f of x, which is minus 2x plus 1, right? That is minus of f of x. So if x is minus 2 times minus 2 is plus 4 plus 1 is 5. If x is minus 1, minus 2 plus 1, minus 2 times minus 1 is plus 2 plus 1 is 3. If it is 0, then it is 1. For 1, it will be minus 2 plus 1, which is minus 1. And for 2, minus 4 plus 1 will give us minus 3. So what do you observe? As far as the y points are concerned, you see for the same x value, the y points are negative of the previous function. And that is what it is meant by negative of f of x. So that is correct. Now let me plot these points and draw the line. So minus 2, 5, so that is minus 2, the scale is up to 4. Let us say this is 5 for us. Minus 1, 3, minus 1, 3 is this point. 0 and 1, so that is that point. 1 and minus 1, so 1 and minus 1 is right there. And 2 and minus 3, 2 and minus 3 will be here, correct? Connect these points to get the function minus fx, right? So we'll connect these points. So once you connect these points, what you observe is that the two lines this is approximate point here, but we're just connecting them. Okay, so this is the function which is for us minus of f of x. Is that okay? So that is the function. Now we can compare the characteristics. One thing which you observe very clearly is that they have one point in common, and the point in common is the x-intercept, right? So x-intercept is the point which is common to both of them. Right? So let me list out the characteristics which we observe. So the first one, which is very prominent here, is x-intercept is common. That means it does not change, right? We call this such points which are common, which do not change, as invariant. So whenever the function and minus of the function is considered, then we'll have invariant points, and those are the x-intercepts. So that is first thing which comes to our mind, right? So that is the invariant point, correct? You can check if x is equals to, if f of x is 0, then x will be equal to half. So for the value of x equal to half, we get y value of 0, and this point is common in both the cases. So that is first thing which we observe. Now you also see that all the points basically are reflected. So if I write down these points as a, b, c, d, and e, let's say these points are a, b, c, d, and e, in that case what is happening to the points is that the e dash is reflected on x-axis. Do you see that? So it is equally far away from x-axis. Similarly, d is also reflected, so that is how you get d dash, right? So what we observe here is that for minus of f of x, if minus of f of x is reflection on x-axis of f of x, so that is how you get minus of f of x. Now in terms of coordinate points, what you will observe is that any point in general, if on f of x the point is, let us say xy, then on minus of f of x, for the same value of x, will have negative y value. So that is how the points will change, right? So you have seen here that xy, and it is x minus of this value. Do you see that? 0 minus 1, 0 plus 1, 1, 1, 1 minus 1. So here the signs have changed for y. So in general, you can write the transformation as the coordinate points xy change to x minus y. So these are the changes which we see on the points on the graph. Now let's talk about the characteristics, right? So let's talk about few characteristics. So amongst the important characteristics, we observe that the earlier graph was increasing, right? So if we write down, let us say f of x and minus of f of x, and then list few characteristics, then what do we see? So first thing we see is the graph was rising, or you can say it was increasing, right? Then minus of fx will be decreasing or falling. Is it okay? So in this case, since it is a line, we can use this term. But in general, it's better to use increasing and decreasing intervals, right? So it increases all throughout, and minus of f of x is decreases all throughout, and that changes the end behavior. Do you see that? So end behavior reverses in this case. So what happens to end behavior when, so in the first case it is from quadrant 3 to quadrant 1, and the second case it is from quadrant 2 to quadrant 4, right? So that is another change which we observe as far as the characteristics are concerned, right? For a linear function, domain range is all real numbers, so even after reflections it remains the same. However, if we take up some functions like square root function, you will find that the domain and range will also change. Domain remaining same, but the range flips, right? That is how it is. Anyway, I'd like you to go through this video, understand what kind of changes will be there in a function when we are considering negative of that function. Okay, this is basically resulting into reflection on x-axis, and that causes all these things which we have mentioned. I hope that helps. Thank you and all the best.